Welcome back. So in the last few videos, we've been talking about JavaScript arrays, which are the first data structure that we've talked about. In the next few videos, we're going to introduce another data structure called the object. So we have two main objectives, just like we did with arrays. We first want to understand what objects are, why we use them, how do they compare to an array, and then the second objective is how do we write some code using JavaScript objects. Let's go ahead and get started. So here's a hypothetical situation. Suppose that I wanted to model a single person. In JavaScript, each person has a name, an age, and a city. So there's a lot of ways I could do that. I could have three different variables, name, age, and city, but then they're not related to one another. They're totally separate. So if I wanted to connect them, I could use an array, like I'm doing here. var person is equal to array, where the first item is name, Cindy, the second item is age, 32, and the last item is Missoula, or the city. This is not really a great use of an array because this data is not really a list. Yes, we can force it into an array, but it doesn't lend itself to the format of an array where we have lists that often have a logical order. There really isn't a logical order here. To access the city out of this array, I would need to write person bracket 2, and that requires me to know that the city is at index 2. So if I accidentally reversed the order and I had Travis as the name up front, index 0, but then I mixed these two up, so I had at index 1 city and age at index 2, then if I tried to access person 2 bracket 2, I would get age instead of city. So this is all just to show that an array is not the perfect solution for every situation. There is a much better data structure for us to use here, which is the JavaScript object. You can see an example down here of how we would take the person array with name, age, and city and turn it into a JavaScript object. The first thing you should notice is that we have curly braces rather than square brackets for an array. The next important piece is that every item in this object is a key value pair. So we have a property, value. Name is Cindy, age is 32, city is Missoula. This slide shows the exact same thing. We have a different person object, var person equals curly braces, and inside that, we're setting name to be Travis, age to be 21, and city to be LA. Down here, we have a simple diagram of what this data structure looks like. We have three different slots in this object, and it's really important to note that objects don't have any built-in order. Unlike an array, where there's a first item and a second item and a third item, think of the items inside of a given object as just floating around inside of there. There isn't an order, no property comes first or second. It doesn't matter how I declare them, in what order, they're all treated the same. So this diagram shows them in an order, but that's just because I had to pick an order. So you can see Travis is stored under the key name, 21 is stored under the key age, and LA is stored under the key city. To retrieve data out of an object, we have two choices. We can either use the name of the object person, square brackets, and then the name of the key. So in this case, I'm getting Travis out of the person object, so I write person, square brackets, name, in quotes. So that's very similar to arrays. The only difference is that this is not a number, this is a string. The other option is to use dot notation. Dot notation is a little bit shorter and simpler. We write person dot name, and name has to match obviously the name of the key, and that will also give us Travis. I'm going to go ahead and demonstrate that in the console. I'm going to make a new object called dog, and my dog is going to have a property name, as always, Rusty. He is the best dog, and we'll have breed. He's a mutt. Lastly, age, and he is 3. So that gives me my object dog. And if we look at it in the console, you can see it tells me it's an object here. Name is Rusty, breed is mutt, age is 3. So if I want to access his age out of the dog object, I can do the first syntax, dog, and then in quotes, age, and I get 3. Or I can do dog.age, and I also get 3. It's up to you to use either one. I prefer to use dog.age because it's shorter. You don't have to use the quotes. You don't need double brackets on either side. You just need dot. But there are a few differences. On this slide, I demonstrate 3 of the main differences. So you cannot use dot notation if the property starts with a number. So you can see that here, SumObject.one blah is not valid. But if I had a property called one blah, I would have to use square brackets and put it in quotes. And that's just the way that it's set up in JavaScript. I'm going to jump down to the third example here, which is that you can't use dot notation if your property name has a space in it, like fav color. Obviously this doesn't work. JavaScript thinks that we're accessing .fav. So if we want a property with a space, which is not really a good practice anyway, but if we did, we would need to use quotes, fav, space color, using square bracket notation. And then the middle example shows that you can look up things using a variable if you use bracket notation. So if I have a variable here called string or str, and it's equal to name in quotes, if I try and do SumObject.str, it will just look for the property str. But if I do SumObject square bracket str, it's going to evaluate str, which gives us name in quotes. So this will then look up the name property in SumObject. So this is something we actually will see occasionally, so it's worth knowing the difference here. You can use square bracket notation using a variable name to look up a property. The next thing that we want to do is be able to update data inside of an object. So it's very similar to arrays, where we access the data and then reassign it with an equal sign. So here you can see we have our same person object, name is Travis, age is 21, city is LA. If I want to add 1 to Travis's age, it's his birthday. All I need to do is access person age. I can use square brackets or the dot notation, and then reassign it. So person age plus equals 1. So that will add 1, and person.age is now 22. Or I can use person.city and reassign that to be London. So person.city equals London will now set person to have city of London. So just to demonstrate that, let's go back to our dog object, which has name as Rusty, breed is mutt, age is 3. Rusty just had a birthday, so I'm going to change his age. Dog.age equals, and I could either do this, equals 4, which is just going to make it 4 no matter what, and I can look at dog, or I could do dog.age plus equals 1, which will just add 1 to the existing age, and that gives us 5. I'll also demonstrate doing that with the square bracket notation. Let's say that I want to change Rusty's name to be his nickname, Tater. I would write dog, square bracket, name, and that just gives me Rusty, and then I'll reassign it to be Tater. And if we look at dog, we now have name, Tater, breed, mutt, age, 5. There are a few different ways of initializing objects, just like we saw with arrays. So we can either make an empty object first, like we have here, var person equals empty curly braces, and then we can add the data after the fact, one piece at a time. Person.name is Travis, person.age is 21, person.city is LA. We can do it all at once, which is what we've seen so far. This is called object literal notation. So var person equals, and then inside the curly braces, I just write my properties. Name, Travis, age, 21, city, LA. And the last way, which you won't see very often until much later in JavaScript, is that I can use the new object, which is a function just like new array, that will make us a new object and return it to us as an empty object. And then I can add person.name, person.age, and person.city. So you'll definitely see this syntax and this syntax much more often for now. Another point I'd like to make about objects is that just like arrays, they can hold any sort of data. So our data can be numbers or strings or booleans, an array, even another object, as you can see here. Just like arrays, we can mix and match as much as we'd like. So we're going to stop here for now. In the next video, we're going to do a comparison between objects and array syntax.